Find the area inside one, I misspelled petal. Sorry about that. There you go, that should be a T. Find the area inside one petal of r equals sine of 2 theta. So first of all, jump over to the graphing calculator and graph r equals sine of 2 theta. So sine of 2 theta, and then I should check on the window. So this should go from 0 to 2 pi. And hey, that's not pi. There's pi. And the biggest that sine gets is 1. So if I have it range from -1 to 1 and -1 to 1, then I should be able to see the whole graph. And then the direction said for one petal. So this at the origin is when r equals 0, and then it's going to graph like this. And I'm thinking that that is going to be pi over 2. So if I go from 0 to pi over 2, let me check. If I go from 0 to pi over 2, is that going to give me one petal? Petal. That's one petal. All right, so 0 to pi over 2 works. Hey, look, there's no error. Excellent. Glad to see it. Good job, calculator. Keep it up. Okay, so we've got a beautiful little graph right here. And then this was going from 0 to pi over 2. And then to find the area, use the idea that area is equal to, you integrate 1/2 r squared d theta. And we've got our limits 0 to pi over 2. So integrate from 0 to pi over 2. And with the 1/2, I'm just going to factor it out. And then the r, which is sine of 2 theta, has to be squared. And you're probably thinking you need a trig identity. And yes, for integrating sine squared, we need to use that sine squared of x is equal to 1 minus cosine of 2x divided by 2. Now, in this case, the x is going to have to be replaced with a 2 theta. So then replace x with a 2 theta, which means that the cosine is going to have a 4 theta. All right, so the 1/2 can sit there minding its own business while I do some calculus. And the sine squared gets replaced with 1 minus cosine. And then it becomes, instead of 2 theta, it becomes a 4 theta. And then for this 2, I'm just going to factor it out so that there's another 1/2 that got factored out. And then we can find the antiderivative. So there's now a 1/4 on the outside. The antiderivative for the 1 is going to be theta. Then bring down the negative sign. The antiderivative of cosine, that's going to be sine of 4 theta. And because of the chain rule, we need to divide by the 4. And then evaluate that from 0 to pi over 2. So keep the 1/4 factored out and then substitute pi over 2. And when you do that with the sign, it's going to say 4 times pi over 2. And then that means we're talking about sine of 2 pi, and sine of 2 pi becomes a 0. So this is just going to get canceled. And the same thing is going to happen when you use the 0, because when you use the 0, theta will be 0. This will be sine of 0, which is also 0. So it turns out that the only thing that's contributing to the answer is this nice little pi over 2 right here. And then it's going to be 1/4 of that. Oh, I guess I could just finish this one up, can't I? Just multiply across and I get pi over 8. So that's the area for one petal.